this is Jack Jackson again. We're going to be looking at practice test 5B today. Remember that this part of the test, the calculator is allowed. We have just 10 questions here, so let's jump right in and work through these. Find the dimensions of a rectangular Persian rug whose perimeter is 32 feet and whose area is 63 feet. So it's a rectangle, so let's just kind of sketch it out here and see what we know. We have a width and a length here, and of course the length here and the width here. So we have 2 lengths plus 2 widths has got to be the perimeter. But we know that the perimeter is 32 feet. So we have 2L plus 2W equals 32. So there's one equation. And we also know the area is length times width. But we also know the area is 63 square feet. So we got length times width is 63. So we can solve for these two sides. Okay. Let me start with this bottom one and divide both sides by 2 and get that down to length plus width equals 16. And let's solve for width in terms of length or vice versa. So we'll say the width is 16 minus the length. Now I can take that and put it in place of W in the other equation. So length times 16 minus the length has to be 63. Alright, so let's distribute here. 16L minus L squared equals 63. And let's get 0 on the, let's do it on the left. And I get L squared minus 16L plus 63 equals 0. And now we want to factor this out. Let's try to see if we can just do it with sort of anti-FOIL factoring. If not, we can of course use the quadratic formula. To get L squared has to be L and L. To get 63, we can try 1 and 63, 3 and 21, 7 and 9. And we want these to add up to 16, so I believe the 7 and 9 will work. Notice that's positive, so they have the same sign. That's negative, so they'll both be negative. So let's check that out with FOIL. L times L is L squared. Negative 7 times negative 9 is 63, positive. Negative 7L plus negative 9L is negative 16. So now we have two things multiplied together to be 0, and very important that that's 0. So that means either one of these two has to be 0. Either L minus 7 equals 0, or L minus 9 equals 0. So L is 7, or L is 9. Now, W is 16 minus L. So if L is 7, W is 16 minus 7, which is 9. And over here, W is 16 minus 9, which is 7. So basically, one of these is 7 and the other one is 9, either way you slice it. So the shorter side is 7 here, and the longer one is 9, and they're, of course, in feet. Alright, next question. Okay, after declining between 1940 and 1980, the number of multi-generational households has been increasing since 1980. The function here, let me go ahead and write it down, h of x equals 0.012x squared minus 0.583x plus 35.723. You know what? Let's go ahead and put that in our calculator. I'll be using a TI-84 since that's what most of you have. There's something similar. So 0.012x squared minus 0.583x plus 35.723. Okay, so now we have that in there, so we can use the features of our calculator to help us out if we need to. So let's see where we are now. Okay, so that's the number of multi-generational things. X is years since 1940. So year number minus 1940 will be X. And what year were there 40 million generational households? and y is, okay, notice that h or y is in millions already. So 40 million, that means y or h is 40. So we're solving this equation. 40 equals this. So we're solving this equation. Well, I would get 0 on one side and then use the quadratic formula. Or I can just take this, and since I have a calculator, I'm asking when this is equal to 40. So I'm just graphing this and seeing when they cross. So let's start at 0, and I don't know how it went to, it looks like it was probably going down and then back up some. Starts at 30, so x is 0. Year 1940 starts at about 36, and it's supposed to go down and back up. So let's go, we want it to be 40 eventually, so let's go up to like 60. No, 60 for the y. So like 0 to 60 for y. And tens is fine. And then for x, well, let's try 60 years for x also. And let's see what happens here. Okay, not a bad window, and we do see our point of intersection, which is our main thing we want to get. And so we can see that by just calculating that. Calculating that point of intersection. Enter. Enter. Go over here to the guess. I could also type in a number if I know about where it is. So get over here close to it for the guess and hit enter. And it looks like about 55. Now there's another one in another year, but earlier, according to this model, before 1940, but it just says that this formula is estimating from 1940 on. So I think the one they're looking for, the only one they're looking for, is when x is 55. Of course, that's since 1940, so 1940 plus 55 is 1995. And that's what we have for the answer there. Okay, so the next one is 15x cubed plus 22x squared minus 5x times x squared minus 5 equals 0. We want to factor this, solve the equation. They boil down to the same thing. So this one, let's see what we can do here. I can factor out an x out of this. And I will drop all these powers down one. So I know for sure one answer is when x is equal to 0. Okay? Another two answers I get from x squared minus 5 equals 0. That says x squared equals 5, x equals plus or minus the square root of 5. So I've got, here are my x's here. I've got 0, I've got square root of 5, I've got negative square root of 5, and there's two more coming from this. So I want 15x squared plus 22x minus 5 equal to 0. So let's see what I can do with that. Maybe I can do just trial and error factoring, 15x and x. I can get 5x and 3x. So those are our two possibilities. And then for 5, I got 1 and 5. 1 positive, 1 negative. Okay, I'm not going to put the 5 with these two, otherwise I could factor 5 out of this, which I can't. So I could try the 5 here and the 1 here. That would give 3x and 25x. They need to be opposite signs. Hey, sure enough, that subtracts to get 22. This one positive, this one negative. Excuse me. So, I believe that'll work. So this one doesn't work, but this one does. 5x minus 1 and 3x plus 5. So this one says x is 1/5. When you put that equal to 0, when you put this one equal to 0, that gets x equals negative 5/3. So if I look back at the original, I could have actually factored that. Of course, we've got 0, but this factored version, it factors as an x, a 5x minus 1, 3x plus 5, and this one actually factors as x plus the square root of 5 and x minus square root of 5. In fact, I can go ahead and factor the 3 and the 5 out and get my leading coefficient of 15, and so this is the overall factored form. So I'm factoring a 5 out of that, so it's x minus 1/5. This is x plus 5/3. This is x plus square root of 5 and x minus square root of 5. And so we see that each one of these answers, there's an x somewhere, there it is. That one corresponds to 0. This one's the negative square root of 5. This one gives you the positive square root of 5. This gives you the negative 5/3, and this one gives you the positive 1/5. So each factor corresponds to a root or 0 or solution to the equation. And so they want the solutions without the braces. So in some order, type in those 5 numbers. Now, since I didn't use a calculator on that, I didn't have to. But since I have a calculator, let me show you a couple other things you could have done. We could have done 15x cubed plus 22x squared minus 5x, parentheses, x squared minus 5, and we want to see where this crosses the x-axis. Okay, now the square root of 5 and minus square root of 5 we're not going to get exactly, but we should approximately be able to get that. And this other part we can get exactly. So let's just graph this. Let's just start with the zoom standard. And we're looking for places where this is equal to 0, so where it's crossing the x-axis. So not necessarily the best window for the overall view, but I can see some x-intercepts here. 1, 2, maybe another 1 or 2 in there, probably 2 in there, and then 1 there. So 1, 2, 3, 4, 5. Looks like we got all of our roots, so maybe we can actually come in a little bit on the x's. 1, 2, 3, negative 4 to 3 on the x's, but let's go out on y's a little bit. So negative 4 to 3 on x's, but let's go down to negative 50 and up to 50. I don't know if that's good or not. Let's see. Let's look at the graph. Yeah, pretty good. We're missing a minimum right in here, but other than that, that's a pretty decent window. So let's just go with that for working with this. And we can calculate each of these by calculating a 0, number 2. It's also known as a root or an x-intercept. And so negative 1, 2, negative 3 could be the left side. And this one's negative, somewhere between negative 3 and negative 2 we have 1. And I can go over somewhere in there for a guess, and we get an x. If I quit and type an x, now we can try to change it to a fraction. Well, that's an irrational number. If you look, that one turns out to be the one that's minus the square root of 5. Should be that one. So that one didn't turn into a fraction because it's an irrational number. Okay? Now let's go back and calculate another 0. We got to do this one at a time. But we can check, how about the next one? Let's get over here across this hump. Okay, so somewhere between there for the left side and there for the right side, and I guess that's pretty good. Hit enter. Okay, 1.6 repeating. So there's that x now. Notice if I change that to a fraction, that's math, enter, enter. Negative 5/3, there it is. That's one of them we're looking for. So that means negative 5/3 is a root, negative 5/3 comma 0 is an x-intercept, and x plus 5/3 is one of our factors. Let's keep going. It's pretty easy to see x factors out of this, so that we know x equals 0 is a root, goes through the origin, but let's actually look at it on the, calculate it from the graph here. So we might want to zoom in right in this part right here, but it's actually touching twice. It's touching here close and then comes back down. So the first one, so let's get over here close by. They're kind of close together. It might be useful to zoom in a bit, but let's see if we can do it without. So enter. Now look at the y values. They're negative, 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 negative. Positive. That's the first one that's positive. So I'm going to use that both as my right bound and my guess. And look at that, 0, 0. So that means that 0 is a root, and that also means just x is a factor. Now if you look closely, it doesn't actually touch and turn around at 0. Remember, the y's went positive when we were a little bit more into the positive x's. And then it comes back down. So there's another one here that should be the 1/5. Okay, so let's calculate that one. Should turn out to be 0.2. That's 1/5. Let's see. So left bound. Okay, so now y is positive. Hit enter. And as we go further, the y's are coming down. Now y's are negative. That could be our left bound. And our guess close to 0. Hit enter. And x is 0.2. Again, I can change that to a fraction because there's x of 0.2. And then change it to a fraction. And that's 1/5. So that says 1/5 is a root. And x minus 1/5 is a factor. Of course, our leading coefficient is when we factor is going to be, if you multiply this out, it will be 15x to the 5th. So there's our 15. What about their other two factors? Our other two factors are the things that make up x squared minus 5. And so those are x plus the square root of 5 and x minus the square root of 5. Okay? And of course, the square root of 5 we'll see on our last one when we hear. It won't tell us what it is, but it's somewhere between 2 and 3. So I'll give it a left bound of 2, a right bound of 3, and we'll guess 2.5. And it's actually closer to 2.2. And again, there's our x, but this time when you try to change to a fraction, it won't do it. It's irrational. So there we go. We could, of course, double check our factoring by putting the original in y1, which is what I have, and then we could put our factored version right here in y2, and they should match in the table and the graph. Alright, next question. A rocket is fired upward from an initial distance above the ground. The height in feet above the ground t seconds is fired as given by this formula. Okay, now in general, acceleration, when you're measuring in American units, is negative 32 feet per second square. Velocity, and of course that's a constant function as time goes on. The velocity then is the same, negative 32 times t plus our initial velocity, and that's in feet per second. And the height, we'll call it h, t, is half of that, negative 16, then t squared, then v sub 0 t plus initial height, and that's in feet above whatever 0 is, the ground. Okay? So, those are the equations that govern motion when the only force acting on the object is gravity. Now, this neglects any effect of the air, like air resistance. But if we have an object where air doesn't have a lot of effect on it, like may be true for a rocket, then this will approximate things quite well. So notice that we have a constant function here, a linear for constant for acceleration, linear for velocity, and then we end up having quadratic for the height. So anyway, we have this, and so by looking at these numbers, I can tell you what some things are. So for example, the velocity is negative 32t, and the initial velocity is this 80. So our initial velocity is 80 feet per second. And our height is negative 16t squared plus 80t plus 1056. And so our initial height is 1056. So it starts at 1056 feet above the ground. It's shot up at 80 feet per second, and then it flies up, maxes out, and comes back down and hits the ground. So it's starting at a height above the ground, goes up, and then comes back down. So anyway, let's take a look at this and see the maximum height. Well, the maximum height is k, so we need to find our hk. And our h, remember, is minus b over 2a. Okay, so it's the opposite of 80 over 2 times negative 16. Okay, two negatives make a positive. Let's see what we got here. 80 over, let's see, 8. We can cancel an 8 out of that. It's down, actually we can cancel 16 out of that. 5 times 16 is 80. So this is positive 5 halves, or 2.5. So that's h. K is f of h, so that's f of 2.5. So let me just plug in that. So actually I'm going to go to here. Just about any time we have an equation, we're going to go ahead and just type it in here. Negative 16x squared plus 80x plus 1056. Okay, and let me just quit and let's evaluate. Let me do it this way. Some of you have a calculator where you get y1 by going alpha F4 to get y1 like that. Others will have to go variables, right arrow to y variables, choose function y1, and evaluate that at 2.5. And this will tell us 1156, and that's our maximum height. That's our k, the y-coordinate of the vertex. Okay? How long does it take for it to reach its maximum height? That was the 2.5 seconds. So we're just finding the coordinates of the vertex for the first part. Now when does it reach the ground? Now you're solving this equation. 0 equals negative 16t squared plus 80t plus 1056. And so we can just use the quadratic formula on this and work it out. Or, you know what, since we've already got this thing in the calculator, why don't we just graph it? In fact, we could find the maximum that way as well without remembering the vertex formula. So let's figure out what an appropriate window would be. Before x is time, and I don't know how far out in time we need to go yet. I need to go till it hits the ground. Turns out it's going to be 11 seconds, but we didn't know that ahead of time, so we could just put in some number here and just try it out. Trial and error. Let's go 20 seconds. And we know the y, just so I can see the intercept, I'm going to put negative 1, but really I should just start at 0. And then go up to, well, I've already figured it out. 1156 is the top, so let's go 1160, 1160. Maybe we need to mark it off in hundreds there. Okay, and so we should see it shot up, it goes up higher, comes back down, hits the ground. There's no point in really going this far out, so I might just go out, I might just change this and just go out maybe not as far, maybe 12. But I can see the maximum and I can see where it hits the ground. Okay, so let's calculate the maximum. We could do this without knowing the vertex formula. We already know the answer. It's 2.5 comma 1156. That's our HK. That's our coordinates of our vertex. But let's have the calculator figure it. So we can just do calc maximum. Where is it? Second trace is calc. Maximum's number 4. We need to go on the left side. We'll just put in 0. And then the right side, let's keep going until we're on the right side here. Notice we've gone up, and okay, we're definitely on our way back down, so hit enter there. Get over close to where it crosses the top. And there's our maximum, 2.5. Actually, this isn't using an approximation technique, so it's actually off just slightly here. It's actually 2.5 is where it really is. And 1156 is there. So when does it reach the ground? Well, we want to calculate where it hits the ground when the height is 0. Of course, the velocity is not 0, but the height is 0. So we can calculate that 0, and this is why it was useful to go a little beyond where we were. Well, it looked like it was between 11 and 12, wasn't it? So we'll just type in 11 for the left, 12 for the right, maybe 11 and a half for our guess. And boom, there we go. It was 11 actually, and y is 0. I probably should have said between 10 and 12. Maybe let's be careful. Actually, y was 0 there, so that's good. But if we put the n in the wrong place, that can mess this up. So let's try it again. Let's try for a 0, and we know it's between 10 and 12. And we'll guess 11. And yeah, sure enough, 11 is it. So there you go. Of course, you get the same thing by doing the quadratic formula on this particular guy here. Actually, it's a whole number, so we probably could have just factored it using good old anti-FOIL factoring as well. So some multiple options there. Let's quit. Next question. Number 5. The profit of a company in dollars is the difference between the revenue and cost. So, in general, profit equals revenue minus cost. Well, they've given you a formula for revenue and cost, so now we can find the profit as a function of x. The revenue is 760x minus x squared, and the cost is 2,400 plus 40x. Alright, let me just clean this up a bit. We could type it in just like that in the calculator if we wanted, but I'm going to go ahead and distribute this negative and combine some like terms here. Negative x squared minus 40x minus, okay, we've got a calculator, why not use it? Negative 2400 plus 760 negative 1640. Okay, so there's p of x, kind of simplified a bit. There's our profit function. Okay. So notice it's a negative quadratic, so it's gonna, it's gonna have this kind of a shape. Okay, negative leading coefficient. So let's put it in the calculator. Again, I could have just put it in this way also, but it was easier for me to simplify a little bit, I think. So let's do it that way. Just a little cleaner. Alrighty. Now let's see what we want to do to graph it. Well, x represents dollars. X represents the number of items we're making and selling. So, no, we're making actually. So it can't be negative. So I don't know how far out we've got to go. Let's just guess. Let's go out. Let's start 100, and we'll see. This may not be nearly far enough. If we want to do that, maybe we should mark. Come on. Leave that on 1. Maybe mark that off in hundreds. And y's. Well, y can be negative because we could have a negative profit. So typically what happens is we have this, we start negative, we go up, and then it kind of maxes out. Technically it still comes down, but you want to window something like this. So it shows the, that's called the break even. This is going to be the opposite of your startup cost, or your fixed cost. It'll be the opposite of that. And right here, this x is going to be the number to maximize profit. And the y that goes with that, so this is h, this is k, and this will be the max profit. Okay? So, we want a window that will kind of show all that. Well, notice that we're starting at negative 1640, so we need to go that far down. So let's go negative 1700. And I don't know how high. Maybe we get 100. Maybe we go 10,000 at least. Let's do that much. And if we do that, let's mark off in. Let's just start negative 2,000 then. And we'll mark it off in thousands. This may not be a good window, but it's a good place to start. So let's graph that. Oops. Negative, negative. This is plus. Okay, let's graph it again. Ooh, not good. Not good news for this company. Golly, I gotta pay attention more. That should have the X. Alright, so that's going to change a few things. Alright. Let's see what we have here. Negative x squared. These two are the ones that are going to combine terms to give, those are both this negative distributes. That's negative. That's negative. So those are, yeah, two negatives. Okay, so that and that add together to be plus 720x and then minus 2400. Okay, that makes more sense. Okay, so let's get the formula in there. Negative x squared plus 720x minus 2400. Okay, let's see if that graph is more reasonable. Alright, that looks better. We can see the fixed cost, the break-even point. We're not going high enough. How high do we go? Well, I don't know. Let's look at our table. Maybe we start our table and maybe start at 0, maybe go up in tens or something. And let's look at it and see what kind of numbers we get out of this. Okay, well it's going up, starts negative, somewhere between 0 and 10 it crosses over to positives, hits 0 and it goes up to positives. 11,000, 18, 37,000. Still going up, still going up. Okay, still going up. Okay, we made up to 80 something thousand, over 100,000. Okay, whoa, stop. I think I've hit enter too many times and gone way into the negatives. Didn't mean to go hit my arrow too many times. Okay, I see a 31,000. No, it was higher than that. Looked like it's up around 65, 70, oh, above 70, above 80. Did it make it up to 90? Yeah, over 90. Was it over 100,000? Yeah, it's over 100,000 there. Looks like it's above 120,000. What if we just go up to 150,000? Okay. We do that, let's mark it off in thousands. Actually, let's mark it off in 10,000s. Not bad, but we need to go out further on the x's too, because we don't see that maximum. So let's go out 500 on the x's. There we go. We can see the max and come back down. Now there was an easy way to find out what the max was going to be on the x, because remember it's just h, which is the opposite of b over 2a. That's a real easy formula. So we could have done that's 720 over 2 times negative 1. That's 360. So we knew we had to go out past 360 on the x, and go out a little bit further than that, so 500. Now, there we go. So there are things I could ask you about this. The maximum profit's going to be there. How many do you need to make? Well, that needs to be the 360. And then, of course, we can just trace this at 360. And that should be the maximum right there. But of course we can also have this calculated for us. So if you didn't know the vertex formula, you could do calc maximum. Okay, and this would work for things besides quadratics. So if you had a cubic or something like that that had a maximum, you could do this same technique here, whereas the vertex formula only really works for quadratics. Okay, of course the approximation technique was just slightly off, but rounded off definitely 360, and then we see the y value there, 127,200. Okay, another thing they could have asked you in this type of question, let's just do this, is the break-even point, and that's when y is 0, when revenue and cost are even, they equal each other. And so that would be a calc 0, and it's somewhere between 0 on the left and, I don't know, we just need to go to the right here till well, we're already positive, so somewhere between there and there. let's go there for our guess. And that's the break-even point. So once you've made 3.34891, or somewhere between the third and fourth item, you've turned your profit into positive. Technically, it crosses the x-axis again later, but that one doesn't really count because there's no way you can get there without making the product, letting it sit on the shelf and not selling it. Nobody is that stupid to do that, so nobody's going to do that. Find the zeros of this polynomial. Okay, f of x equals 6x cubed minus x squared minus 384x plus 64. Well, if you've got a calculator, just graph it. 6x cubed. Now, it's a cubic, so we're looking for 3 roots. Some of them may be the same root more than once, but we're looking for 3 places where this touches the x-axis, or possibly some multiple roots. I don't know what to start with. Let's just start with the zoom standard. Okay, there's one, there's another one, and there's another one. So we've got, we can see our 3 things. Actually, we can work with what we've got here because we can see where it crosses the axis, but I'm going to leave my x's alone, but I'm going to go out on my y's a bit. Let's go negative 200 to 200. Maybe mark it off in tens. Better. I still can't see the max and min there, so I'm going to go out a little further. I can work with what I've got. I don't have to do this, but I'm going to do it anyway. Let's go out 1,000. Negative 1,000 to 1,000. Maybe mark it off in hundreds. Not bad. It's just a little off the screen. Let's go just a little bit more so we can see the max and min, and so we can see that shape. Again, I don't really have to do this part. I do need to see those x-intercepts is what I really need to see. But I think if we go out to here, oh, just almost. That's irritating. Well, let's go on it just a little bit more. On the top. Bottom's okay. Let's go up another 100. Now, I could have used my table to help me get there a little faster, perhaps. But there's our, yeah, that's what you expect for a cubic, right? Leading coefficient 6, so they're positive, so the right side's going to go up. Cubic, odd power, so the opposite arrow, opposite direction on the other end. It's going to cross the axis up to 3 times. In fact, it does cross 3 times. Let's see if we can find what those are by just using our calculator. Calculate a 0. Well, let's just do this one here. Left side, right side, and then our guess. That's good enough. Let's see what we get. Okay, let's quit. Change that x. That's the x we get. Change it to a fraction. So x is an element of this set. So if f of x equals 0, then x is 1/6. So that means this factors, we got a 6 out front, then this factors is x minus 1/6. And we got 2 other factors for the other 2 roots. Let's see if we can figure out what those are. Each factor will correspond to a root, and of course each one of these corresponds to an x-intercept. Okay, so let's see what we can do with the rest. Well, we just calculate those as well. Let's calculate another 0. Looks like we got something between 7 and 9 at least. So let's go from 7. There we are. Let's make sure we get on the other side. That's the left side. Yeah, that's good for the right side. Guess. Looks like that's exactly 8. Okay, so that means over here, that's the one on the right, 8. So that means x minus 8 is a root. The x minus 1/6 was the one in the middle, so I'll put that one in the middle. Doesn't matter what order you put them in. I'm just doing it this way. And what do we get for this other one? So 8, 0 is an x-intercept, 8's a root or 0. X minus 8's a factor. 1, 6 is the root. 1, 6, comma 0 is an x-intercept. X minus 1, 6 is a factor. We got this other one. 1, 2, 3, 4, 5, 6, 7, 8, 9. From, it looks like between negative 9 and negative 7 or so. So let's calculate that again. Another 0. Was negative 9 on the left side? I think so. Yeah, that's good. And then let's get something on the right side. That's good. And then a guess. That'll work. And negative 8. And notice this says y is 0. It's approximately 0. This is 0.9 zeros and then a 1. Well, that's practically 0. So negative 8, so it says x plus 8 is a factor. Negative 8 is the answer here, and negative 8, 0 is this. They're looking for these roots here first. And notice they all have powers of 1 here, so they all have multiplicity 1, which is evidenced by the fact that it just kind of goes straight through on the graph. All right. Next. Okay, number 7. Come on up here. Just thinking. Okay, so we've got g of x is negative 1/2 x plus 5 x minus 2 square x plus 1. Now, actually, I can do this without a calculator, but we're going to check it with the calculator in a minute. So, when x is negative 1, it touches the axis. When x is positive 2, it touches the x-axis. And when x is negative 5. Now, if you multiply all this out, you get negative 1/2 x to the 1, 2, 3, 4, plus some other terms. So I know on the ends it's going to look like an x to the negative 4. So the end part of it, over here and here, it looks like this. So once it gets past this guy here, it's eventually going to come down like this. Now this 1 at 2 is a multiplicity 2 root, so it's going to touch and turn around there at that one. Okay, at that point. Okay, which means somewhere in here it turns around and goes up through this one. And somewhere it turns around and comes down through this one here. So we're going to get that basic kind of a shape, and right there that limits you to A. Okay, but let's verify that with the calculator. I mean, we've got a calculator, so let's just graph it and see what happens. So negative 1/2 times x plus 5, and then x minus 2 square, and then an x plus 1. Okay, and look at all these windows. They go from negative 10 to 10 and negative 100 to 100. So negative 10 to 10, negative 100 to 100. And on the x's, they're marked, the grid is spaced in, actually in 2's. And on the y's, the grid is spaced in 20's. I think. Okay, so let's look at the graph. Yep, that's A. Sure enough. Okay, let's go on. Next question. Factor it and solve the equation. Well, those really go hand in hand. Factoring it and solving the equation are really the same thing. They're different ways of writing the answer, of course, but the skills that are involved are the same. Because once every factor corresponds to a root. Now we're going to use the calculator to do this. We're going to put it in the non-factored version, the original version, what they give us. We're going to just put that in here. Okay, I can see right off the bat the y-intercept is 0, negative 70, which we may or may not want to see, but can't really tell what the roots are. So let's try this. Let's just start with well, let's start with the zoom standard, and then we'll modify from there. Okay, looks like I see a root there. There's one there, one there, one there. We're looking for 4 altogether. Well, it looks like you can see all 4 of them here. Can't really see these minimums down here. We know negative 70 might be decent. This might not be the best. Actually, we can probably work with this window right here because we can see what we need to see. But I'm going to expand out a little bit on the y's just for the heck of it here. So let's go negative 200 to 100 here and mark that off in tens, and then see what our graph looks like. Yeah, that's a pretty good window. We're missing a minimum here. This continues down, mins out somewhere way down here, comes back up, but we can see the end behavior. X to the 4th, positive 1 coefficient, goes up on the right. Arrows go the same direction, so it's up on the left here. So this is coming down from left to right. Multiplicity 1 root here, multiplicity 1 root here, here, and here. So all of these are going to factor as x plus or minus a number, and there's going to be 4 factors, and there's going to be 4 roots. And so if we're graph f of x equals 0, then x will be, there'll be 4 numbers here. Each one corresponds to a factor, and each one corresponds to an x-intercept. So let's just find them. We'll start here on the far left. 1, 2, 3, 4, 5, 6, 7, 8. Looks like about negative 7, but let's check it out. So we can calculate 0. We think it's somewhere between negative 9 and negative 8, and we're going to guess negative 7. Oops, something I did didn't work right for that. Let's try that again. Calculate. I don't think I typed what I meant to type. Okay. Okay, that's fine. We're on the left side there. Okay, that's enter. And then let's go see if we can get on the right side. Okay, enter. And we'll guess something in the middle here. That's good. Enter. Yep, negative 7. This is basically 0. Point 10 zeros and a 9. That's 0 basically. And then x is negative 7. So negative 7 is here, and that means x plus 7 is your factor here. So your factors and roots kind of go together. Okay, let's do this next one. Of course, this where it crosses the y-axis is 0, negative 70. We're looking at this one here. It looks like it's around 1. So let's calculate that one. Calculate another 0. It's somewhere between 0 there, and let's get to the right side. Alright, that's on the right side. Come back for our guess. There. Sure enough, it's 1. So then this is x minus 1. Okay, let's see about the next one. Is it 2 or something? I don't know. Let's see. Let's calculate. Another 0. Okay, let's get over that hump if we can. Okay, there we go. It's still on the left side. Hit enter. Move over to the right side. Yeah, there we're at the right side. Get that close to y0. Hit enter. 2. Yep, sure enough, 2. So that means that x minus 2 is a factor. And finally, there's one more over here. Let's go ahead and calculate that one. Calculate that 0. Must be 5. Let's see here. Enter. Go to the other side. Enter. Back to our guess. Enter. Yep, sure enough, it's 5. Okay, 5. So x minus 5 is a factor. So there's your factors, and there are your roots or zeros, solutions to that equation. 1, 2, 5, and negative 7. Shouldn't matter what order you type that. And then those are the factors. It should have asked us for factors. It told us to do it that way. We actually found the roots and then found the factors from them, but they go hand in hand, right? Each root and each factor corresponds. In this case, they're all multiplicity 1 roots because the powers are all 1. And of course we saw that on the calculator because it just kind of goes straight through the axis there. Oh, okay, now we get some rational functions. 4x cubed over x squared minus 25. If we factor the denominator, that's x plus 5 and x minus 5. So we see the domain is all reals except for negative 5 and 5. Okay, and nothing cancels here, so that means these are going to be vertical asymptotes. So vertical asymptotes are x equals negative 5 and x equals 5. So if we look over here to graph somewhere, we find 5 and negative 5. Those are not part of the graph, but it'll get close to those things. And then horizontal asymptotes, you look at the first terms here. This will be a power function, p of x, 4x cubed over x squared. This is 4x. So that means we have a slanted asymptote with slope of 4x. Now, 4. It's kind of like 4x. Now, it might be shifted. So to find that, we actually do long division. If you want to find the slanted asymptote, we actually have to do it this way. 0x squared, 0x, 0 here. So 4x cubed divided by x squared is 4x times that's 4x cubed minus 100x. Change the signs and add. That's 100x. That's it. So when this works out, this could also be written as 4x plus 100x over x squared minus 25. So as x gets bigger and bigger and bigger, this part gets closer to 0. So it does, sure enough, get close to the line y equals 4x. So y equals 4x is a slanted or oblique asymptote. So we have 2 vertical asymptotes and 1 slant asymptote, which is what we have here. And now what would the graph look like? Well, 4x is, somewhere in here. Some slanted line here going through the origin. It looks something like that. So my guess is probably up in here you've got asymptotes going this way, and the last piece maybe let's go down here. Maybe down in here and then in between. Who knows? Looks like when x is 0, y is 0, so it goes through here. Could go through here, could go the other direction. Let's just graph it on the calculator and see which one it is. Hard to know exactly, but we do have some asymptotes there. Okay, parentheses around the numerator, 4x cubed, divided by parentheses around the denominator, x squared minus 25. And, well, we'll use their window, negative 10 to 10, negative 100 to 100. Negative 10 to 10, that's already in there. Almost there. Negative 100 to 100. Okay, and let's see what we get for a window, for a graph. Yep, there we go. If, just to check out your asymptotes, well, you can see, let's see if we can draw. We can draw a vertical line at x equals 5. We'll do that in a minute. Let's graph y equals 4x and see if that's our slanted asymptote. Let's make the graph itself thicker. Okay. So there's your actual graph, and then there's your 4x. So if we were to zoom out a bit beyond what they have, like negative 20 to 20, we should see a little bit better this end behavior, and maybe negative, we'll double this, negative 200 to 200. Mark that off in 50s. Now, you can start to see now more of that straight line shape on the ends. Yeah, that looks like that's going right. And to see our vertical ones here, of course, one way we could do is just look at our table. Let's go to table. Let's just start at -10 to going up by ones. And we see that at -5 we get an error message. And we're going to get an error message at +5 as well. There's our 0, 0 going through the origin. Yep, error message at 5. So that's your vertical lines there, and you can kind of see that. You can kind of see it there on the graph as well. You can kind of see the asymptote. Okay, so anyway, which one is that? Okay, actually these two are quite close. So that's a bit tricky to see what it is here. Okay, they've got the asymptote in here. What is this asymptote? So the slope of this asymptote, let's see what's our scale. We're going to the right. Yeah, these are 2. So we're going to the right 4. So that's a delta x of 4. And we're going up 1 mark here, which is 1, 2, 3, 4, 5, 20. So that's a slope of 5. That's not quite what we needed. We needed a slope of 4. Okay, so let's try this one and see if it's better. Okay, so here we're going 5 to the right. That's our 5 to the right. So 5 is our delta x, and our delta y is 20, and that's a slope of 4. Okay, there we go. That's more like it. Okay, that's the right asymptote there, and you can see the dotted lines for the vertical asymptotes at 5. So it looks like that's going to be the one. It's a little bit, had to investigate kind of a little close there. This one, they're just in the wrong place, which you can see pretty quickly from the graph on the calculator. Of course, if I had to do this without a calculator, then I'd have to go in and, you've got to plot some points at some point. You can have the calculator do it for you, you can do it yourself. But at some point you have to plot some points. Okay, so here we go. Here's another one. F of x equals x minus 6 over x plus 5. Okay, find all kinds of cool stuff about this. Well, the domain is going to be all reals except for what makes the bottom 0, which is -5. If you do that in interval notation, that's -infinity to -5, union -5 to infinity. And that's the domain. They want to use it interval notation, so they want it in this form. Alright, what makes, and it doesn't cancel, so that means x equals -5 is a vertical asymptote. What makes the top 0, which would be 6, top 0 and bottom not 0, that's an x-intercept. Plug in y, x is 0, and you can figure out what y is. It's -6/5. That's a y-intercept, if we need that. What about horizontal, about an end behavior? Just look at the first terms, x over x is 1, so y equals 1 is what it looks like on the ends. So that's since that's a constant, that's a horizontal asymptote. So let's see if we can work it out here. So the domain is there. The x-intercept is 6, 0. The y-intercept is 0, -6/5. Okay. Vertical asymptote, it had 1, x equals -5. Horizontal asymptote, it had 1, y equals 1. Oblique, no oblique asymptotes. If it has, it'll either have horizontal oblique or none, or neither. And then we got to figure out the graph. Now, what we should see just from looking at this, just from this information, okay, let's just see what we've got so far. Kind of put this together. okay, we should see at 6, 0 should touch the axis. Okay, we should see 0, negative, well, just a little bigger than 1 and 1.2. So there's where it touches the y-axis. Y equals 1, horizontal asymptote. Oops, come back here. And x equals negative 5, vertical asymptote. Okay, now we're down here and here. My guess is from this that it's going to go up like that, come down here. We need to plot some points, but it looks something like that. It could be either down here or up here. We need to check a point, so let's try negative 6 and see where that puts us. Negative 6 minus 6 is negative 12. Negative 6 minus 5 is negative 1, so that puts us at 12. So that's quite a ways up here. So it looks like it's probably going to look something like that. Okay, so which one of those looks like that? Let's see. There's a piece down here and a piece. Okay, so the pieces are here and here. So it's either this one or this one of these two. But where's the asymptote? The asymptote should be over here in the negatives for the vertical. And at, oh, did I forget this? Yes, I did make a mistake. No, I did not. Horizontal should be at 1. Positive 1. Yeah. So we're right here. This one up here, 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 here. This should be what we're dealing with there. So this is what the graph should look like if we do it exactly. Now, of course, you got a calculator, so hey, just graph the thing. You don't have to figure all this stuff out without the calculator. You can use the calculator. So x minus 6 divided by x plus 5. Should have cleared it first. Get rid of all this other stuff. Okay. Zoom standard is what they've got. Yeah, like that. I mean, that's probably enough to be able to figure it out there all by itself. The asymptotes, y equals 1 was an asymptote, so we think. So we decided already. We don't think, we know. But if you graph that, it's a little hard to see here, but if we zoom out a bit, we should see that. So let's double everything. Now you're seeing it there. We can see it in our table too. When we put in our table, notice as we go that at negative 5 we get an error. Okay, so negative 5 is where our vertical asymptote is. If we go way out here on the negatives, the y's should be getting, notice they're above 1, but they're getting closer and closer to 1. If we go way out there, we could try something and see that it's real close to 1. Maybe I'll just do this. We'll start at negative 100 and just go up by 5s. So if you're way out there, like negative 100, yeah, we're real close to 1 and getting closer. Whereas if we're up here at notice here we get an error message there. As we go further out here to the right, they're below 1, but getting closer and closer to 1. So if we go something way out here, it'll be real close to 1. So we can see those things there in our calculator as well. So you can use your calculator for things. Some things you can do without your calculator. Do the combination. Okay, I believe that's the last one, so we'll close it up there, and hopefully you can use that to help you study for your exams. As always, the exams will be quite similar to the practice test. Not necessarily exactly the same, Certainly could be some of the same problems with slight changes to the numbers because they're algorithmically generated. The graphs and numbers and formulas could change a little bit from one to one, but the same kinds of things, or something very similar to this. Possibly a little shorter, but this will be about what you could expect for the actual exam.